All right, hello and welcome to the second in our series of video lectures. Today we are going to be talking about slopes and how to find them. Okay, so first question, what is a slope? Outside of a pretty fun word to say, slope is simply the rise or fall of a line. In day-to-day life, you encounter slopes all the time. It's, how angled the ground you're walking on is. If the ground is angled upwards and you are going uphill, we call that a positive slope, okay? And if it's going downhill, all right, we call that a negative slope. Now, something to look at right here, notice that we are reading these graphs the same way you read a book, and this is really important. We read graphs from left to right, always. This will come back and be more important in just a second. All right, so why do we care about the slope of a line? All right, so last class we were talking about relationships, right? And we were talking about how a graph shows us as scientists or business people or whomever the relationship between two variables, right? One variable is on the x-axis, one variable is on the y-axis. What a slope of that line shows us is it shows us the rate of change between those two variables, all right? And what that means is if that line is really steep, okay, that means that one variable has a huge effect on the other variable, okay? Whereas if the line is really flat, it means that the changing in one variable doesn't have a big change in the other, okay? Slope shows us the relationship between these two variables, all right? Now, remember, there's two types of relationships we talked about last class. The first one was a direct relationship, okay? When we see an uphill slope, okay, when it's going uphill, that's called a positive slope, and that is a direct relationship. So when one variable increases, it makes another variable increase. The more water you give a plant, the more it's going to grow, okay, right? And the opposite of that is also true. Negative slopes show inverse relationships, okay? Meaning as, I'll show you here, meaning as this variable on the bottom, as the x variable gets bigger, right? Because here's x is equal to 0, x is 1, 2, 3, 4, etc. As this variable is getting bigger, this variable on the y-axis is getting smaller. It's going closer to 0, it's going down, okay? And again, how angled this line is shows us how much it's changing it. If it's a really steep line, that means just a little change in the x variable causes a huge change in the y variable, right? Whereas if it's a really flat line, a big change in the x variable only has a small change in the y variable, right? Another way to see these, if you haven't picked up on the bicycle or the skiing metaphor here, is negative slopes always go downhill. This is an inverse relationship, okay? Right? As x gets bigger, y gets smaller. An uphill is a positive or direct relationship. As the x variable increases and goes away from 0, the y variable goes up. If a line is flat, that means that as the x variable changes, nothing happens, right? Like you could say the x variable is how many raisins I eat a day, right? And notice as I eat more raisins, 1, 2, 3, 4, as this variable increases, let's say the y variable is fluctuations in the stock market, right? My eating of raisins has 0 effect on the stock market, right? This is what we call a zero variable or zero slope, and that means that there is no relationship between the two. If you ever get a graph line that goes straight up and down, this is what we call an undefined slope. There is no slope, and honestly, something probably went wrong in your experiment because you should never, ever, ever see this, okay? We're only gonna focus on these three here. So the big question, and what we're really after today, is how do we calculate the slope of a line? All right, as with everything this year, I'm gonna show you a bulletproof, 100% accurate way. And if you follow these steps, you will calculate the slope of a line correctly every single time, all right? So let's go through these steps. So here is our graph, all right? And what we have here is our first step. Okay, so first step is we need to find 2 points on the line, okay? The line has to be straight. If it's curved, there's no slope, all right? So here we have a straight line. So we're gonna find our 2 points. I'm gonna pick this point and this point, okay? Draw dots on your 2 points, okay? Draw the graph, put your dots there. Number 2, you gotta find the X value and the Y value for those points. So how do we do this? All right, what you need to do is you gotta make this chart. And this may seem like an extra step or it may seem kind of childish, but it's super important. So what I'm gonna do is I'm gonna make myself a chart, okay? I'm gonna have the X, the Y, I'm gonna have my first point, and I'm gonna have my second point, okay? So here's your chart. Now, we have to figure out which one's my first point and which one's my second point. The same way that we read, okay? Your first point is always gonna be the one towards the left. So we always read a graph like this. So as you go, the farthest left point is 1, and the right-hand side point is 2. Okay, it doesn't matter if this one's higher and this one's lower. The one on the left is always 1. Okay, this is 1, and the one on the right is always 2. So let's find our values. Now here, this graph doesn't have it labeled, but I know what my values are here. So let's say that this is 1, 2 on the x-axis, and let's say that this is 1, 2 on the y-axis. Let's say it goes up to 3, 4, and let's say it goes to 1, 2. Let's call this 6. Okay, so here are my lines here. All right, so point number 1. The first thing we're going to do is find our x and y. The way you find your x and your y coordinates. For the x coordinate, remember this is the x-axis. Okay, the horizontal, the flat one is x. All right? So we go to the dot and we go down to the x-axis. And we see what number is there. My x-axis point is 2. So I'm going to put a 2 in my chart. I do the same thing with my y-axis. Remember, y goes to the sky. Right? Y is going vertical. We go from the point over to the y-axis, and our y point is also a 2. Right? We now have to do the same thing with our second point. Okay? We go from our point and we go down. Okay? Our x-axis point, our x2 is 6. Right? This is our second point. Right? 2, 2. The x value is 6. And we do the same thing with our y value. Y goes to the sky. Y is the vertical axis. So I'm going to go from this point all the way over to the y-axis. And my y variable is 4. Bam. Okay. I have my chart. I have my 2 variables. Okay. The second or third step, technically, is you got to remember this equation. Okay. The equation to find slope, okay, is y2 minus y1 divided by x2 minus x1. This is a very important equation, and this is one that is not going to be given to you on any test, okay? 95% of the equations that you need this year will be given to you on an equation sheet. This one is one that we got to remember. We got to remember slope, so it's really important. Now you may be sitting there and thinking, I remember slope. I remember how to remember this. You might remember this phrase right here. Rise over run. What does that mean? Well, look, your y-axis rises. It goes up, right? Y to the sky. So here we call this the change in y. This little triangle means change. Okay, if you ever see this triangle, this is the Greek letter delta, and it means something is changing. Our y value is changing. Okay, in this case, our y value is going up. So we have change in y, also known as rise, over the change in x, which we call run. Okay, and we call it run because it's going flat this way. Rise over run. Okay, this is what we're trying to find. So, from our equation, I'm going to write down the equation, because you should always write down the equation. I'll actually write it down in a different color so you can see it. So I have y2 minus y1 divided by x2 minus x1. Now we just have to fill in our numbers, go to the chart. So you have y2 is 4, right? That's my y value for my second point. So I put in a 4, minus, okay, y1, which is the y value of my first point, y1, which is 2. And I'm going to divide that, okay, by my second x value. So here is x2 is 6, minus, okay, my x1 value, x1 is 2. Now all I have to do is this very basic subtraction. And again, you always do the denominator and the numerator, or the top and the bottom of the fraction separately. Don't put this into your calculator. I always suggest putting every step into your calculator individually, because if you put them all in, if you make one little mistake, right, while you're trying to type everything, if you forget a parentheses or put plus instead of minus, the whole thing's ruined. So it's really easy to just go, all right, what's 4 minus 2? That equals 2, divided by what's 6 minus 2? That is 4. And the last thing you have to do is put 2 divided by 4 into your calculator, which will give you 1/2, which, as I'm sure you know, equals 0.5. And again, you'll always have a calculator, so you can put that in there. All right? This looks complicated, and it is a lot of math. Okay? Well, it's a lot of writing. It's not really a lot of math. But I promise you, we're going to do some examples, and if you just use this method, one, the more you practice it with me, the better you will be at it, okay? And two, the more you see it, the more this equation will always be in your brain. Say it to yourself over and over. Rise over run, 2 minus 1. Rise over run, 2 minus 1. Rise over run, 2 minus 1. I'm going to say it 1,000,000 times. I want to sound like a broken record, because the more you repeat something, the more you remember it. All right, take a look. Let's go to our next example. All right, let me just double check that I'm still recording. I want to make sure. Okay. I've given you this slide. This is a fantastic slide. It does switch the 2's and the 1's. So when you're looking at this, okay, I don't necessarily like this. Okay, I like to call these 1 and these 2. Okay? In most instances, this will give you the right answer, but I like to change that. This is beautiful though. If you are more visually inclined, okay, there is a way of doing this without the equation. I don't recommend it, okay, but if you feel really strong with your math skills, especially if you really dominated some earlier math classes, you may remember that you can just count your slope, right? Because it is the change in y over the change in x, or rise over run. Well, if you have graph paper, you can count what that changes. Look here. We're going from this point to this point. So how much does it rise? Well, it goes from here up 1 block, meaning my rise is up 1. Okay? My run goes from this point to this point. Okay, so my run is 1, 2, 3 blocks. It's that portion right there, meaning my run is 1, 2, 3. So here, my slope is just 1 divided by 3. Okay? Again, we'll look at a couple examples so you can get this straight. I gave you another example here. Here's your equation. X1 and Y1 are always furthest on the left. I like it like this. This is the way I do it. So consistency is king. If you do it the same way over and over, okay, you will master whatever art it is that you're doing. That's what learning is. It's just practicing. Okay? So again, here we have Y1 and Y2. All right? So let's look at a couple examples. We're going to run through these together. Let's practice. What is the slope of this line? All right, so let's do this together. Step 1, pick 2 points. You can pick any 2 points on the line. Does not matter because the slope of the line is the same everywhere. I suggest avoiding the negative area, okay? This is 0, right? This is 0, 0, 0x, 0y. Anything in the negative, over here or down here, if you can avoid it because it makes it tricky. So I'm going to pick, this is my first point, and this is my second point, okay? Second thing, okay, we're going to make a chart. We're going to make it up here. So we have x and y, okay, 1 and 2. Here's my chart. All right, let's look at our first point here. Here's point number 1. What is the x value of this point? Remember, to find the x value, you go down to the x-axis. And I go from my point down to the x-axis. Well, my x value is 0. Okay. All right. And my y value, well, I'm on the y-axis. My y value is 1. Remember, y goes to the sky. This is always y. This is always x. My second point I have right here. To find my x2, this is 1. 2. To find my 2, I go down to x, 2. And I notice right here, this is 2, this is 4, so I'm on 3. Okay? And then to find my y value, I go over to the y axis. And my y value is right there, it's 2. Now, I use the same equation. Change in y over change in x. Rise over run, rise over run, 2 minus 1. 2 minus 1. Every time. Plug in my numbers. Y2, I go to my chart. Y2 is 2. Y1. Y1 is 1 minus 1. Okay. X2 minus X1. X2 is 3. Minus X1 is 0. Do this math. 2 minus 1 is 1. Divided by 3 minus 0. 3 minus 0 is 3. And that is my slope. You can put this into your calculator and you will get 0.33. 1 divided by 3 is 0.33. It is very important to notice, okay, before you calculate the slope, ask yourself, is it going to be positive, negative, or 0? How do we know that? Well, look at the line. Is the line going uphill or downhill? This one is going uphill. So I know I have to get a positive number. If you get a negative number and the slope is positive, double check your points, double check your equation. Rise over run, 2 minus 1. Okay, it's always the second value minus the first value. Rise over run, 2 minus 1. Okay? And again, you can just double check. It's rise 1 divided by run 3. Well, let's look here. We rise up from 1 to 2. That's 1. And we go over 1, 2, 3. Rise over run. 1 divided by 3. With me? Remember, if I'm speaking too quickly, you can always click the gear icon and slow me down to 75%, okay? You won't hurt my feelings. I'll try to go slower, all right? And you can always pause, you can always go back, you can always find me online every day for tutoring if you have questions. All right, second example. First up, we see that the slope of this line is negative, so we know we're going to get a negative value. Okay, but we're going to do all the steps anyways. First step, make a chart. X, Y, 1, 2. Get our numbers. All right. The left point is always the first point. It's always point 1. This is always point 2. The one on the left is always 1. I don't care if it's higher or lower. So let's look at our values here. Our x value, well, our x value is 0. Our y value is it's on the y-axis, is 5. Okay. Our second point, our x value is 4. And our y value is on the y-axis, it is 2. Okay? Our equation, change in y over change in x, this equals y2 minus y1. Rise over run, 2 minus 1, divided by x2 minus x1, 2 minus 1. Plug in the numbers. y2 is 2, minus y1, which is 5, divided by x2. x2 is 4, minus x1, which is 0. This gives me 2 minus 5. Remember, you got to put the numbers in the way they are, okay? 2 minus 5 is negative 3, divided by 4 minus 0. 4 minus 0 is 4. So we have negative 3 divided by 4. We have negative 3 because, look, our rise doesn't rise, it falls. And it falls down 1, 2, 3, which is why this is negative 3. It's going down, okay? But our run is positive, and it goes 1, 2, 3, 4. So we get negative 3/4, which if you put that in a calculator, you'll get negative 0.75. That's the answer. I didn't say this before, but I will tell you this while we're in synchronous learning. I strongly recommend that you pause these, draw a simple version of this graph or the other graphs, and write down these equations with me so you have a sheet of known problems that you can work from, okay? You can use these to practice yourself, okay? And see what's going on. All right, last one. All right, the first thing you should look at, ask yourself, is this line going up or down? The answer is obviously, no, it's not. So what is the slope of this line? Well, the slope is the rise or fall of the line. In this case, the slope is 0, okay? So we should get 0, but let's calculate it just to be sure. First step, pick 2 points. I'm not gonna pick any negative points. I'm gonna pick this point and that point. Okay, x1, x, y, 1, 2. Always make a chart. If you do the same thing over and over, it turns into muscle memory, all right? Our first point, our x value is, our x value is 1, and our y value, this is our y-axis, is 5, okay? Second point, our x value is 3, and our y value is also 5, okay? Rise over run, 2 minus 1, okay? y2 minus y1 over x2 minus x1. We plug our numbers in. We get y2. y2 is 5 minus y1 is 1 divided by x2 is 3 minus x1 is 1. We do this math. I'm going to bring it down here. Do the top first. 5 minus 5. 5 minus 5 is 0. Divided by 3 minus 1. 3 minus 1 is 2. And 0 divided by 2 equals big fat goose egg. Okay? So we just proved mathematically that the slope of this line is in fact 0. So now you've seen a positive slope calculation, a negative slope calculation, and a 0 slope calculation. Okay? Using this chart and this equation, you can answer all of the questions about slope from here for always. Over the next couple of weeks, we're going to be working a lot with graphs, and one of the most important things will be finding the slope, okay? We're going to see this a lot. There's a reason we're taking one day for it. So go back, work these practice problems, okay? Write them down. See if you can work them out yourself and get the right answer before I actually show you how to do it. All right, guys? Okay, I'm going to sign off. Have a great day. Again, if you ever have any questions, email me at rnorris@dallasisd.org or find me at tutoring every day and every flex day. All right, guys, be well.